A Bingham fluid, this is a type of non-Newtonian fluid of viscosity 10 Pascal second. This is again in MKS. And yield stress, which is tau 0 is equal to 10 kilopascal, is sheared between flat parallel plates separated by a distance 10 raised to minus 3 meter. The top plate is moving with the velocity 1 meter per second. The shear stress on the plate is, you have to calculate it, and there are 4 options: 10, 20, 30 or 40 kilopascal. This problem is from Newtonian and non-Newtonian or Newton's law of viscosity. Newtonian fluids are the fluid which obeys Newton's law of viscosity, and the one who does not obey, they are called as non-Newtonian fluids. And Bingham fluid is one of the type of non-Newtonian fluids, and the best example is toothpaste. So when you do a brush in the morning, the toothpaste, it won't easily come out from the tube. You need some initial stress, and that stress is called as yield stress, and afterward it flows smoothly. So let's see the solution. So tau equal to mu into du by dy is the Newton's law of viscosity. Obviously the sign is negative. I hope you already studied this, that negative sign indicate that as distance from the center of the wall, you can say, either increases, if y is 0 over here, the velocity is decreases. So if you remember, if it is laminar flow region, the velocity profile is parabolic in nature. So as y increases, u decreases. So that's the reason the negative sign is. Tau is shear stress, which is Newton per meter square. Du by dy is shear rate, which is second inverse, and proportionality constant is viscosity, or you can call it as a dynamic viscosity. Now, for Bingham plastic fluids, the equation will become du by dy. Now, this sign is just indication of negative, but when you wrote it's basically a positive, so it's kind of something like this. So tau equal to tau 0 plus mu du by dy. Tau 0 is already given, which is yield stress, which is 10 kilopascal, you can see, plus, viscosity is also given, which is 10 Pascal second. Du by dy, so velocity is given, which is 1 meter per second. It is good that all the values are given in MK system, you don't have to convert it. And dy is 10 raised to minus 3 meter. So if you substitute this in the equation, 10 plus mu is 10 into du is 1 divided by dy is 10 raised to minus 3. So yes, this 10 is in kilopascal and all are in, basically this should be 10,000. I hope you understand it. into 10 raised to 3 Pascal. So now Pascal second, meter per second and meter. So 10,000 plus now 10 into 1 by 10 raised to minus 3. So when it goes up, it becomes 10 raised to plus 3, and 10 into 10 raised to 3 is become again 10,000 plus, you can see 1, 2 and 3. So 10,000 plus 10,000 becomes 20,000 Pascal, or you can write 20 kilopascal. So the value of yield stress is 10 kilopascal. So let us see the options. Yes, the second option is 10 kilopascal.